Welcome to the lesson on the geometrical meaning of the zeros of a polynomial. At the end of this lesson, you will be able to define a polynomial and its basic terminology. You will also be able to identify the zeros of a polynomial by plotting it on a graph. Consider the expression 5x cubed minus 2x squared minus x plus 2. This expression is called a polynomial. A polynomial is an algebraic expression consisting of multiple terms. The terms of a polynomial can be variables or variables raised to a power of a whole number, a constant, or the product of these two. The real number that precedes the variable is called the coefficient. For example, in this polynomial, 5, 2 and 1 are the coefficients. In this polynomial, there is only one variable, x. Such a polynomial is called a polynomial in one variable. If x is the variable in a polynomial, then the polynomial is denoted by f of x, p of x, q of x, and so on. The highest part of the variable of a polynomial is called the degree of the polynomial. Based on its degree, a polynomial can be called as linear polynomial, quadratic polynomial, cubic polynomial, and so on. Since the highest degree of this polynomial is 3, this is a cubic polynomial. The general form of a cubic polynomial is ax cubed plus bx squared plus cx plus d, where a, b, c and d are real numbers, and a is not equal to 0. Here's a second example. As the highest degree of this polynomial is 1, it is a linear polynomial. This is read as p of x is equal to 4x plus 8. The general form of a linear polynomial is ax plus b, where a and b are real numbers and a is not equal to 0. Consider the third polynomial, x squared minus 4x plus 3. Here the highest degree is 2. Such a polynomial is called a quadratic polynomial. The general form of a quadratic polynomial is ax squared plus bx plus c, where a, b and c are real numbers and a is not equal to 0. Now that we have reviewed the definition of a polynomial, let's move on to define the zero of a polynomial. Consider the quadratic polynomial x squared minus 4x plus 3. Let's substitute the value of x as 1 in the polynomial and simplify it. We get the value of the polynomial as 0. This implies that p of 1 is equal to 0. Here the value 0 is the value of the polynomial when the value of x is equal to 1. Now, let's substitute the value of x as minus 1. On simplifying, we get the value of the polynomial as 8. This implies that p of minus 1 is equal to 8. Here the value 8 is called the value of the polynomial when x is equal to minus 1. In general, the value of a polynomial p of x when x is equal to k is the value obtained by substituting x as k. Here k is a real number and the value of the polynomial is denoted by p of k. Now in the first case, the value of the polynomial is 0 when the value of x is 1, which is the value of x, and it is called the zero of the polynomial. The zero of the polynomial is defined as any real value of x, for which the value of the polynomial becomes 0. In general, a real number k is a zero of a polynomial p of x if p of k is equal to 0. Let's discuss the geometrical meaning of the zeros of a polynomial. Here, we will see the graphical representation of a polynomial. Consider the linear polynomial 4x plus 8. Assume that the polynomial is equal to y. To determine the geometrical meaning of the zeros of this polynomial, we'll have to plot this equation on the graph. You must first determine the points representing the x and the y coordinates. For this, we'll assume a few values for x. Substituting these values of x in the equation and simplifying it will give us the values of y. This table gives the x coordinates and the corresponding y coordinates. The x coordinate and the corresponding y coordinate together form an ordered pair that represents a point. Let's locate these points on the graph. On joining all these points, we get a straight line. As you can see, this line intersects the x-axis at the point -2, 0. This means that the line intersects the x-axis when x is equal to -2. As per the definition of the zero of a polynomial, the zero of this linear polynomial is -8/4. This implies that the zero of this polynomial is -2. Based on these observations, we can conclude that the x-coordinate of the point where the graph intersects the x-axis is the zero of the polynomial. In general, if a polynomial p of x intersects the x-axis at k, 0, then we can say that k is the zero of the polynomial. In other words, p of k is equal to 0. The graph of a linear polynomial intersects the x-axis at a maximum of 1 point. Therefore, a linear polynomial has a maximum of 1, 0. Similarly, we can plot the graphs for quadratic and cubic polynomials. You can also find the zeros of these polynomials by identifying the points where the graphs of the polynomials intersect the x-axis. Let's summarize the observations from the graphs. The graph of a quadratic polynomial intersects the x-axis at a maximum of 2 points. Therefore, a quadratic polynomial can have a maximum of 2 zeros, 1, 2, or no zeros. In case of a quadratic polynomial, the shape of the graph is a parabola. The shape of the parabola of a quadratic polynomial depends on the coefficient of x square. If a is greater than 0, then the parabola opens upwards. If a is less than 0, then the parabola opens downwards. The graph of a cubic polynomial intersects the x-axis at a maximum of 3 points. Therefore, it has maximum of 3 zeros. That is, it can have 1, 2, 3, or no zeros. In general, an nth degree polynomial intersects the x-axis at a maximum of n points. Therefore, an nth degree polynomial has a maximum of n zeros. You have reached the end of this section. Before moving on to the next section, let's recap the key points. The x-coordinate of the point where the graph of a polynomial intersects the x-axis is called the zero of the polynomial. An nth degree polynomial intersects the x-axis at a maximum of n points, and therefore has a maximum of n zeros. The graph of a quadratic polynomial is a parabola. The shape of a parabola of a quadratic polynomial depends on the coefficient of x square. If a is greater than 0, then the graph is a parabola that opens upwards. If a is less than 0, then the graph is a parabola that opens downwards.